Dear students, welcome to the lecture series on the topic engineering graphics. So today we are going to discuss about special cases of the applications of the auxiliary planes. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now we have already discussed in our previous deliberations that the two views of an object, front view and top view, projected on the principal planes, vertical plane and the horizontal plane, are sometimes not sufficient to convey all the information regarding the object. The additional views, which are called the auxiliary views, are therefore projected onto other planes which are known as the auxiliary planes. So these planes are auxiliary inclined plane and the auxiliary vertical plane. So auxiliary views they have many applications in engineering graphics, and they are used for determination of true length of an oblique line, point view of a line, edge view of a plane, shortest distance between point and a line, shortest distance between skew lines, then obtaining the true size and form of the oblique plane, and obtaining auxiliary views and shapes of sections of solids. So the auxiliary views, they are very useful in finding solutions of problems in practical solid geometry. So in today's lecture we are going to talk about the point view of a line, the edge view of a plane, and determination of the true size and form of an oblique plane. Now the special cases, applications of the auxiliary planes, now we are going to pick up in today's lecture. Now this is a solid which has been cut by an oblique plane. So this is a cube which we have originally, and this is a cube of edge 100 millimeter which has been cut by an oblique cutting plane as shown in this figure. Now we have to draw the true shape of this cut section by using the auxiliary plane method. Now to begin with, you see, we are going to draw the front view of this solid, that is the cube, after the cutting has been done. Similarly, we are going to draw the top view of the cut solid, and thereafter we will see how different principles of rotation of line and the auxiliary plane principles we are going to apply in order to obtain the true shape of this cut section. And the name of this cut section we have listed as A, B and C. So it starts from A over here, then B and then C. So this becomes basically an oblique triangular lamina. So we'll see that how this triangular lamina appears to us in the front view as well as in the top view, and then we'll see how we are able to successfully obtain the true shape and true size of this cut section using the auxiliary plane method. So now we are going to draw the front view. As I told you, you see, we are looking from this side. As we are looking from this side, the front view will appear to be like this. You can see this is 100 millimeter. Then this is 25 millimeter. From this side, the cutting plane has cut the solid. So this portion was 75 millimeter and the uncut portion remains as 25 millimeter. Then you can see this is the B dash point which corresponds to this capital B. Similarly, this A point will be appearing over here. So this will be called A dash, and the C point which lies around 10 millimeter from the bottom, you can see 12 millimeter from the bottom. So point C dash will be appearing in the front view. So this is A dash which is corresponding to this point A. This will be at the corner over here, corner of this cube, it will be appearing. Similarly, this is B point which is 25 millimeter from the rightmost corner. So this gives us point B dash. Similarly, 12 mm from the bottom left corner we get point C dash. So this is our front view. Let us draw the top view also. So this gives us the front view. Now you bring the projector lines down. Now looking from the top, you can check over here. This is uncut portion, this is uncut portion. So this is uncut portion of the cube. Again this is uncut portion of the cube. Then this is 25 millimeter. So you see this 25 millimeter was there. So this we have marked it over here. Similarly, from this end, the cutting plane is cutting this cube or the solid 15 millimeter from this end. So just see, this distance happens to be 15 millimeter where point A will be located in the top view. So just see, we have marked point A 15 millimeter from this corner. So this, from this corner you have 15 millimeter where point A, that is the top view of the point A, will be located. Similarly, point C, from the top view this point will be appearing at the corner over here. So point C appears at the topmost corner of the uncut cube. Similarly, point B will be appearing 25 millimeter from this particular corner. So this way, the front view of this triangular lamina or the triangular oblique sectioned plane we have obtained. Similarly, you have A, B, C. This is the top view of the sectioned plane with ABC which has been obtained. Now we can see over here once again, here A dash, B dash. So this section of the elevation which has been cut, that is the cut portion A dash, B dash, we work out that since A dash, B dash happens to be parallel to XY, please check this out once again. This is my cut portion, A dash, B dash and C dash. So here I have A, B and C. So in the front view, I am able to visualize it very clearly that the portion A dash, B dash, that is the segment or the edge A dash, B dash of the cut section out of ABC is parallel to my XY reference line. So since A dash, B dash edge happens to be parallel to XY reference line, so in the top view, this edge AB which appears to me over here, this gives me my true length of the edge AB. So out of this total triangle, I am able to work the true length of one of the edge. This is what we were doing in the earlier cases as well. So we remember what we have already done. We need to work out the true length of one of the edges of this triangular lamina or the triangular cut section. And once we are able to obtain true length of one of the edges, I am going to extend this true length and draw another auxiliary plane perpendicular to this extended true length which I have obtained in step number 1. So please see, I am now going to extend this true length which has been obtained. So whatever true length AB is there, I am going to extend it by another 10 to 15 millimeter. Why now little bit more? Because I want to go clear of this corner. So from this corner, this distance should be 8 to 12 millimeter. So maximum 1 centimeter space I can leave. So that's why this distance extension will be around approximately 15 to 17 millimeters approximately. So I want to leave reasonable distance between this corner and this auxiliary plane. And since I am drawing this perpendicular to the edge which was lying in plan, so this is my AVP. So X1, Y1 is an AVP which I have drawn perpendicular to the true length which has been extended, and onto this AVP I am going to derive my auxiliary elevation of this triangular cut section. So please see, if I draw the projections over here, I can draw one projector line through C, I can draw another projector line through A and B. Now let me mark the distance of C. I know this distance of C dash from the XY line. So since this is the auxiliary elevation which I have to draw, so the distances of the elevation from the XY reference plane I need to work out. So you can see the distance of C dash from XY line is known to me. It is equal to 12 millimeter. So I'll mark this distance, measure this distance and mark this distance onto the projector line which is coming through corner C or point C. So 12 millimeter here I am going to mark. Similarly, what is the distance of points A dash and B dash from XY? I know this is the edge 100 millimeter. So this 100 millimeter is the distance of A dash, 100 millimeter is the distance of point B dash from the XY line. And since now A and B, they both lie on the same projector line, so the projections of A1 dash and B1 dash, they are going to coincide, and this distance will again be 100 millimeter. So this distance is equal to 100 millimeter, this distance is equal to 12 millimeter, and then once I join, what do I get? As usual, whenever I go perpendicular to any true length which has been obtained, and onto that particular auxiliary plane, the projection which will be obtained of the lamina will be an edge view. And since this is the edge view of the cut section ABC, just see, it is the edge view of the cut section which is ABC. Now I need to go parallel to this. So another auxiliary plane, this was AVP. Now I am going to draw AIP, because any plane which is drawn parallel to the elevation points will be AIP. Now this is the auxiliary front view which I had drawn. Now the auxiliary top view is the next view which I am going to draw. So the name of this plane is now AIP, and on AIP, any projection which will be obtained on AIP will be called auxiliary plan. And since auxiliary plan is to be drawn here, so the distances of the plan I need to work out. Now please see, this is elevation, this is plan, this is again elevation, and again plan I am required to draw over here. Now if I have to draw plan, I need to work out the distances of the plan from the intermediate. This is my intermediate auxiliary plane or AVP which I had drawn, x1, y1. Now you see these distances, they become redundant over here. Now the distances which will be applicable will be the ones which are there from the intermediate auxiliary plane, that is AVP. Now I need to work out the distances of point A, point B and point C from the x1, y1 reference line. So here the distance of point B from x1, y1 will be this much. Distance of point A from the intermediate reference plane, auxiliary plane, x1, y1 will be this much, and distance of point C from x1, y1 will be this much. So these three distances I need to take care of and plot it and mark them over here in the auxiliary plan view. So let us take the point C. So point C, I know this is the distance, this is my coordinate projection line. I will be marking this distance with the help of the divider. So I'll mark this distance with the help of divider and then mark it over here. So once you measure it through divider over here, same distance ahead of the plane I have to mark for C2. Similarly for B, you can check. This is the distance which my plan view is having from the AVP, that is x1, y1. So I'll mark this distance over here with the help of once again the divider. Similarly, the third distance is there, that is distance of point A from x1, y1. So I'll measure this distance with the help of the divider and then mark it using divider from x2, y2. So having marked all these points A2, B2 and C2, that is the auxiliary plan which is obtained on AIP, I know that since I had drawn my AIP parallel to the edge view of the line, so any projection, any auxiliary view which is obtained with respect to the edge view of the lamina or the cut section will be giving me the true shape of this sectioned view. So whatever section was there, I am able to obtain the true shape of this section using auxiliary plane method. So now I can measure the angles over there, I can measure the three edges of the cut section, and accordingly I will be getting the exact shape and exact size of this cut section ABC which was appearing after the cutting was done by the cutting plane. Now the next question, special case we are going to pick up is that of a curved surface. Up till now the few questions that we have discussed, they were about working out the true shapes of the oblique planes or the oblique laminas which were inclined to HP and VP, but they were having only flat edges. In first case we had discussed triangles. In the other case we have also determined the true shape of a trapezoidal section as well in our earlier discussions. But now today you see we have another problem, special case, where other than, you can see this is a lamina which is having one straight edge, second straight edge, and again another one straight edge which is inclined. So three straight edges are there, and then the fourth side, it is no longer a straight edge, it is a suitable curve. So it is an appropriate curve. And then another example, another thing we are going to pick up in this particular question is that the top view is freehand curve. We can draw freehand curve as per our liking. Now another thing which we need to work out over here is that we have to complete the front view of this particular lamina, that is lamina which is having a curved section, but this is a missing section. So usually you see we are plotting all the points forward, but in this case we have to carry out the backward interpolation or backward tracking of this curve, and we'll be able to see that how auxiliary plane method can be appropriately deployed, not only to work out the true shape of this lamina which is involving the curved sections, but using auxiliary plane method we will be able to complete this missing portion of the front view of the curved lamina. So this is a flat surface whose dimensions they have been given. So this is the front view, this is the top view. So using the auxiliary plane method, two things we are going to carry out. First, determine the true shape of this lamina which is involving straight edges and one curved edge. Second thing, we are going to complete this missing curved section over here using the auxiliary plane method. So basic fundamentals, they will remain same. So first things first, first thing is that we need to plot whatever data has been provided to us. So the shape of the front view and the top view is given to us. This is a suitable curve. I can draw this curve like this, I can draw this curve like this, I can draw this curve like this. So whichever way I draw this curve, this is going to derive my construction of the curve in the front view. And besides this, we'll see how we can follow the simple steps of the auxiliary plane method to evaluate the true shape of this lamina which is involving the straight lines as well as the curved surfaces over there. So first things first, that is, let us draw the basic data. So just see, we have drawn the basic data over here. So after drawing the basic data, now we need to start working upon the principles of the auxiliary planes. So please check this out once again. This is our endeavor. A dash B dash happens to be parallel to XY. You can see this construction over here. Since A dash B dash happens to be parallel to this intermediate plane reference line XY, so the projection which is obtained in the plan, that is A1 B1, this projection will give us the true length of the line AB. That is, this was a lamina which was having 1, 2 and 3 straight edges, and it was having one curved edge. So out of these 4 edges, I need to, because this is my endeavor, to work out true length of one of the edges. Even if there are 100 edges, even if there are infinite number of edges, I am least bothered about that. My main endeavor is to work out true length of one of the edges, and having worked out the true length of one of the edges, I will be going perpendicular to that particular true length which has been extended, and onto that auxiliary plane the view which I am going to obtain will be my edge view, and having obtained the edge view, I'll go parallel to the edge view, my true shape of the lamina will be obtained, irrespective whether it is having the straight edges, irrespective whether it is having the curved edges. So let us follow the same principle. Since A dash B dash happens to be parallel to XY, so A1 B1, just see A1 B1, so A dash B dash is parallel to XY, so A1 B1 is my true length. Just see, I have marked the true length over here as A1 B1. Now what I am going to do, as usual, I am going to extend this true length. So usually I say extended by 1 centimeter or nearby, but since I have to go clear of the picture, so my now auxiliary plane should be drawn here. Why? Because I don't want to draw auxiliary plane which is going to intersect or interfere with the existing figure or the projection which I have already got. So please see, I am going to extend this reasonably long, because otherwise if I draw an auxiliary plane here, it is going to intersect with or interfere with my front view and the top view. So I have to draw my auxiliary plane with AVP, because I am drawing it corresponding to A1 B1, which are the plan point. So any projection which is drawn corresponding to the plan points will be AVP. And you can see this is the auxiliary plane or the AVP which I have drawn. So AVP X1 Y1 has been drawn perpendicular to the true length which has been projected and which has been extended. So this was my true length. Why this was the true length? Because A dash B dash happened to be parallel to XY. So using rotation of line method, you see basic principles of projections of line, this view, that is A1 B1, gives me my true length of the edge AB of this lamina. So AB was A1 B1 was my true length. So I have extended this true length. I have drawn an AVP, auxiliary vertical plane, perpendicular to this true length. And having drawn this, we know this very well, that now all these points A dash, B dash, C dash and D dash, these are 4 points of the elevation which I have to project over here. So let us see. Now I am going to draw the projector lines through A, B, C, D over here. I am going to mark the distances of elevation onto this particular AVP. So let us do that. Please check this out. Projection of D. I am going to start with D. Where is my D? Just see, here lies my D. So what is this distance? This distance is not provided. So once again, I leave a reasonable distance. Over here, minimum should be there around 1 centimeter. So approximate distance I know, but then I'll measure this distance using the divider. So once I measure this distance from the distance of the point D dash from the intermediate reference line, which is my XY, this distance is measured, and having measured this distance, I am going to mark this distance on the locus line. You can see it is the projector which is coming through the point D over here. This is my point D. Then I'll mark this distance on the projector which is coming through point D. Now second point is C. So again I'll measure the distance of point C dash from the XY reference line. So this is my distance which I am going to measure through my divider with the help of my divider or a scale or a compass. So once I measure this distance, now where is the locus of C? This is the C1. So through this locus I am going to draw this projector line, and this distance I am going to mark onto this projector which is coming through C1. So name of this point will be C1 dash. Similarly A and B, this is my projector line, but distance of A dash and B dash from the XY reference line will be equal. Why this is equal? Because A dash B dash happens to be parallel to the XY reference line. So since A dash B dash happens to be parallel to the XY reference line, so this distance, whatever distance I measure with using my compass or the divider, same distance I am going to transfer it over here. And once I obtain all these 4 points, A1 dash, B1 dash, C1 dash and D1 dash. So having obtained these 4 points, I am going to join it with the help of a straight line and we'll find out that all these points, they are lying on the same line. So one thing we need to remember, that whatever may be the number of points, there may be 10 points, there may be 100 points in the elevation, all those points, they will be falling on this vertical line. So having worked this out, now before drawing the true shape, I am going to complete this curve using auxiliary plane fundamentals. So as I told you just in a while before, that even if there are hundreds of points over there in the elevation, all those hundreds of points would be converging on, will be merging on this line, straight line. Now in order to complete this curve, you see what I have to do. You can have 1, 2, 3 or 4 dummy points over there, because this curve we had drawn freehand. This curve we had drawn freehand. So some people will draw curve like this, some people will draw curve having lesser curvature, and this is another curvature which I have taken. So whatever is the curvature of this curve, it doesn't matter, because this is a suitable curve or a freehand curve. So you can, once you draw this freehand curve, you can mark 3 or 4 points onto this curve. So just see A1, B1, C1 and D1. These are the points which are already available, A dash, B dash, C dash, D dash, and they corresponding to the straight line segments of this particular lamina. But regarding this curved segment, you can have 3 points or you can have 4 points. So I have taken 3 points which are again appropriately or equally spaced between A1 and D1 onto this curve. So this curve I have divided into 1, 2, 3, 4 sections. So how I can divide it? I'll mark 3 more points over here. So the first point, which is an artificial or imaginary point onto this curve, I have named it as E1. Second point, I have named it as F1. Third point, I have named it as G1. You can have one more point. It doesn't matter. You can have 10 points, you can have 6 points. So I have taken for convenience 3 points only. Having taken the 3 points, had this portion not been missing, please see, had this curved portion not been missing, what would have happened? We would have got E1 and E1 dash in the same straight line. We would have got F1 and F1 dash in the same straight line. We would have got G1 and G1 dash in the same straight line, because otherwise you can check A dash and A1, they are in the same straight line. B dash and B1, they are in the same straight line. C dash and C1, they are in same straight line. D dash and D1 over here, they are also in the same straight line. So had this portion not been missing, so E1 dash, F1 dash and G1 dash would have lied on the same locus. So just see, I have marked these points over here. Having marked 3 points, now I have taken these 3 points onto this straight line. So why I have taken these points on this straight line? Because any number of points which were there, they will all be falling on this edge view, because the edge view is one thing which is a truth. So even if there are 100 points on this curve, all the 100 points would be lying on this straight line. Now you see what I have done. Having marked these 3 points, E1, F1, G1 over here, I have projected these points onto my edge view, drawing projector lines parallel to the earlier ones, or drawing projectors perpendicular to the oblique to the auxiliary plane x1, y1. Now I know these points, E1 dash, F1 dash and G1 dash. What are these points? These points are nothing but they are providing me the distance of the elevation points from the XY reference line, because otherwise A1 dash, B1 dash I had marked like this, forward iteration. C dash and D dash again I had marked over here using forward iteration. Now E1 dash, F1 dash and G1 dash will be projected back using the backward iteration. So just see, if I draw horizontal locus lines over here, back, back and back. So I know that E1 dash, sorry, E dash will be lying over here, F dash will be lying on this locus line, G dash will be lying on this locus line. But I do not know the distances of these points E dash, F dash and G dash from the XY. So this is missing link because the forward curve was not there. Had the forward curve been there, all these points would have been projected over here. Now I know the locations of these points E1 dash, F1 dash and G1 dash using my edge view. So my edge view gives me the location of E1 dash. So what is the location of E1 dash? Please check. Again I'll open this divider. After opening the divider, I'll keep one leg of the divider needle here. Second leg of the needle of the divider I am going to keep here. So I'll measure this distance for the reverse iteration, backward iteration. So this would have been the distance of E dash point had I got the curve available over here. So since this curve is not available, first of all what I have done, I have worked out the locus line of the E dash. Now I have worked out the distance of this point from the XY line. So this distance gives me the distance of E dash from the XY line. So what I'll do now, reverse iteration. So I know the horizontal line locus, I know the distance. So I'll transfer this distance of E1 dash, that is X1 Y1 to E1 dash distance I'll measure, and then I'll keep the needle of the compass here. I'll keep the second end of the needle over here, so that this distance, that is distance of E dash from XY, this one would be equal to distance of E1 dash from the X1 Y1. Similarly, for F1, this is my locus line. If I bring this F1 over here onto my edge view, I know this is going to be my distance. So I measure this distance using my divider and then retrace, that is once again backtrack this distance behind the XY line onto this locus line. Similarly, for G, I know the horizontal line locus of G dash. Now I have projected it forward. So I know that this is the distance of my elevation point G dash in the front view. So I'll measure this distance using divider, and then from XY I'll back project this distance over here. So having marked E dash, F dash and G dash distances from XY, which are equal to distances of E1 dash, F1 dash and G1 dash from X1 Y1, 1, 2 and 3. This is 1, this is 2, this is 3. So having marked these distances in the backtracking mode, I know the locations of this points E dash, F dash and G dash, which are lying on the curve in the front view. Now once again I'll draw another freehand curve passing from A dash to D dash and passing through points E dash, F dash and G dash. So this is the way we can complete the missing section of the curve which was there in the front view. So the incomplete oblique plane, that is the missing curve, has been completed using the auxiliary plane method. And now having obtained this curve, now my next objective is to evaluate the true shape. Now the front view of this curve has been completed, the top view of the curve is already completed, the edge view of the curve has been obtained, and having obtained the edge view, now I will go parallel to this. So again I am going to leave around 10 millimeter distance over here between this existing edge view and the new auxiliary plane. So this was AVP, so this plane is now AIP. Why? Because we have drawn it parallel to the elevation projection line. So this is my elevation auxiliary view. So any view which is drawn parallel to auxiliary view, if which is for the front view, this will be AIP. So new auxiliary plane, which is my X2 Y2, which is an AIP, has been drawn. So I know these points A1 dash, B1 dash, C1 dash, D1 dash, and now 3 points for the curve E1 dash, F1 dash and G1 dash. So all these 7 points have been projected perpendicular to this new auxiliary plane, which is an AIP, that is X2 Y2. Now I need to measure the distances because this is the plan view. Any view which is drawn on AIP will be auxiliary plan. So for drawing auxiliary plan, the distances of the plan will be required, but these distances, they have become redundant now because the intermediate auxiliary plane is this one. So please see, now for all these points A1, B1, C1, D1, E1, F1, G1, the distances with respect to X1, Y1 like this will be applicable. For A, this distance will be used. In order to draw B2, this distance will be used. In order to draw C2, this distance will be used. In order to draw D2, this distance will be used. For E2, this distance will be used. For F2, this distance will be used, and G2, this distance will be used. So we'll check out the points over here, and accordingly on their projectors we are going to mark these distances. So please check this out. This is what we are getting. I'll just show you. For point A, just see, for point A, this is the distance, check this one. For point B, this is the distance, so I have marked it over here. This is my distance for the B. For C, this is the distance of C1 from X1, Y1. So just see, this is the locus of C, 1 dash, and I'll project it from here. From this X2, Y2, I have to measure all these distances. So this is distance of C2. Similarly, D2, just see, this is the distance of D2. So I'll measure this distance, put it over here. Similarly, distances of E, F and G, they have been marked over here. And since this view I have obtained after going parallel to the edge view of the lamina, and this view will be my true shape of this lamina, which was having 3 straight edges and 1 curved edge. So this was 1 curved edge and these are 3 straight edges. And besides obtaining the true shape of this lamina, we have been able to complete this partial or incomplete view which was available with us for the front view. So the incomplete circular portion of this curve has also been completed. So this is how we can draw it. Now I'll just show you how we have drawn it actually onto the drawing sheet. So just see, this was my curve, this was the incomplete portion, this was the actual portion which has been drawn. Now this was true length, we have gone parallel to the true length, edge view has been obtained. Now these distances E1 dash, F1 dash and G1 dash, so they have been back propagated to obtain the incomplete portion of this curve. Having completed this curve, now we have gone parallel to this edge view, and all the distances from X1, Y1, they have been appropriately plotted over here to derive the true shape of this lamina, which is involving straight as well as the circular edges. So this way, that using the auxiliary plane principles, we have seen that how we can not only obtain the true shapes of the straight edge as well as the circular edges, but we have also seen how we can go about completing the missing links in the front views or the top views over here. So this is all about today's discussion regarding the applications of the auxiliary planes. So I hope with this discussion you have been able to understand that how auxiliary plane method can be used to obtain the true shapes of the oblique lamina. So thank you very much. Thanks a lot.